Okay, this is the Final Exam Review, Unit 5. From question 1 here, it tells us that the sequence is arithmetic. So what we need to do is find an expression for the nth term. So one way you can do it is to use the formula. Now the common difference is whatever number is being added or subtracted to each term. And that's 4. And the first term obviously is 3. So if we use the formula, that would be our nth term, 4n minus 1. Or, to generate this form of the nth term automatically, knowing that this is an arithmetic sequence, if there was a term in front of the first term here, it would be -1. And then using the common difference 4 here, we could generate just 4n minus 1 as your nth term. Now, part B, find the 100th term. Now that we have the nth term, we could say the 100th term is just 4 times 100 minus 1, which is 400 minus 1, which is 399. Part C, the sum of the first 100 terms. The formula for the partial sum of an arithmetic sequence is sum equals the number of terms that we're adding, and then the sum of the first term plus the 100th term in this case, because we're adding 100 terms, divided by 2. So this is 50 multiplied by 402, which is 20,100. Okay, question 2. The first row has 15, second row has 17, and each remaining row has 2 more seats than the previous row. So we're adding 2 every time, and it looks like the first term is 15, then 17, then 19, then 21. So the nth term, the common difference is 2, so 2n. And if there was a 0 term or a term in front of the first term, it would be 13. So it's 2n plus 13. So the number of seats on the 20th row is 2 times 20 plus 13. So that's 40 plus 13, which is 53. So there's 53 seats on the 20th row. And the reason we needed to figure out how many seats are on the 20th row is what they're asking, how many seats are in the theater. This is a partial sum of this sequence right here. So we need to find the sum from the first row to the 20th row. And this is the nth term that generates this sequence. So the partial sum is the sum of the 20 terms is 20 terms that we're adding together, and then the first term is 15, the 20th term is 53, and we divide that by 2. So this is 10 multiplied by 68, which is 680 seeds. Okay, now for question 3, geometric sequences was from section 8.3. Find an expression for the nth term. Now, the nth term formula for geometric sequences was first term times the common ratio times n minus 1. So obviously here the first term is 1, and the common ratio is what we're multiplying by to go from term to term, and it's negative 1/2. So the nth term is 1 times negative 1/2 to the n minus 1. So then the sixth term would be using the nth term formula, 6 minus 1. So this is negative 1/2 to the fifth power, which is negative 1/32. And then part C, the partial sum of the first 10 terms. So from n equals 1 to 10. So we need the partial sum of the first 10 terms of this geometric sequence. So the formula for partial sum of a geometric sequence is first term, and then 1 minus r to the n over 1 minus r. So first term is 1, and then 1 minus r, which is negative 1/2, to the power of n, and n is the number of terms we're adding together, so this is 10 over 1 minus negative 1/2. Excuse me. And this is where we would now use a calculator to figure this out. And from this we would get 0.666. Now for question 4, also from 8.3, we're doing this infinite sum. And if you recall, a geometric series only has an infinite sum when r, or the absolute value r, is less than 1. So we first need to figure out r, and r equals 1/5, which is definitely less than 1. So the infinite sum exists, and the formula for the infinite sum is first term over 1 minus r. So this is 1 over 1 minus 1/5, 1 divided by 4/5, which is 5/4. Okay, question 5 says binomial theorem or Pascal's triangle to expand the binomial. Both of these are being raised to the fifth power, so we need 6 rows of Pascal's triangle. Okay, so there are our coefficients. So to begin, on part A, we're going to have 1 times x to the fifth, and then we have a coefficient of 5, and then it's x to the fourth and negative 2 to the first power, and then we have a coefficient of 10. This is x to the third, and then negative 2 squared. Then another coefficient of 10, and this is x squared, negative 2 cubed. Then a coefficient of 5, x to the first power, negative 2 to the fourth power, and finally we have a coefficient of 1 times negative 2 to the fifth power. And then negative 2 to the first power there is negative 2. Negative 2 times 5 is negative 10. So actually need a minus here, not a plus. So minus 10 x to the fourth. Here we have negative 2 squared, which is 4, and then 4 times 10 is 40, so plus 40 x to the cubed. Here negative 2 cubed is 8, negative 8 rather, negative 8 times 10 is negative 80 x squared. Here we have negative 2 to the fourth, which is 16, and then 16 times 5 is 80. So 80 times x, and then negative 2 to the fifth is negative 32. Now for part B, we're going to use the same coefficients because we're raising it to the power of 5. So the first one is first term raised to the fifth power. Then we have a coefficient of 5, and then our first term 2x raised to the fourth power, and then 1 raised to the first power, and a coefficient of 10 with 2x being raised to the third power and 1 squared. Now another 10 with 2x squared and 1 cubed, and then 5, 2x to the first power and 1 to the fourth, plus 1 to the fifth. So then 2x to the fifth power is 32 x to the fifth. And then here we have 2x to the fourth power, which is 16 x to the fourth, and then 16 times 5 is 80. Here we have 2x to the third power, which is 8. 8 times 10 is 80. Here we have 2 squared, which is 4. 4 times 10 is 40. Here we have 2. 2 times 5 is 10. So 10x, and then plus 1. Okay, question 6. Find the coefficient of the term containing b to the fourth for the binomial a plus 3b to the sixth power. So one way we can do this is using binomial coefficient theorem, which would be 6 choose 4. And then if you remember the formula, that's 6 factorial divided by 4 factorial over, or multiplied by n minus r, which is 2 factorial. So this is 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times 2 times 1. 4 cancels there. So we have 6 times 5 divided by 2, which is 15. So the coefficient is 15, but then we need to multiply that by a raised to a certain power and 3b, and that's going to be raised to the fourth power, which means a is going to be squared. So now 3b raised to the fourth power is 81 b to the fourth, and that's multiplied by a. squared, and then that's multiplied by 15. So the coefficient is 15 times 81, which is 1,215 a squared b to the fourth. Now the other way to have come up with this number 15, if we didn't want to do binomial coefficients, would have been to get 7 rows of Pascal's triangle. Oops, 10, 5, 1, and then 1, 6, 15, 15, or 20 rather, and then 15, 6, 1, and then the b to the fourth term would have been that one right there, so you could have found 15 using Pascal's triangle. For part B, if you wanted to use Pascal's triangle, you'd need 11 rows, and you can see how sometimes using Pascal's triangle can get a little cumbersome. It could still work, but if we wanted to do binomial coefficients, it would be 10, choose 4. So this is 10 factorial over 4 factorial multiplied by 10 minus 4, which is 6 factorial. So we have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Then we have 6, 5, 4, 3, 2, 1. And then 4 times 3 times 2 times 1. So the 6, 5, 4, 3, 2, 1 are going to factor out. So we have 10 times 9 times 8 times 7, which is 5,040, divided by 4 times 3 times 2. 4 times 3 is 12. 12 times 2 is 24. So that's going to give us 210. So the coefficient of the whole term is 210, but then that needs to be multiplied by 2a to a power, and then negative b. We want that to the fourth power, so then 2a is going to be multiplied, or raised to the sixth power. So then 2a to the sixth power, 2 to the sixth power is 64. A to the sixth, b to the fourth, and then that's multiplied by 210. So 210 multiplied by 64 is 13,440 a to the sixth, b to the fourth. So the coefficient is 13,440.